Hello students. In the previous class we started with pressure control valve. So these pressure control valves, as you know, are mainly used to protect the system from damage due to excessive pressure. So in the last class we classified these pressure control valves into pressure relief valve, which is again was further classified as direct operated pressure relief valve, pilot operated pressure relief valve, pressure reducing valve, pressure sequence valve, unloading valve, counterbalance valve, and brake valve. So these are the classifications of pressure control valves. In the last class, in detail, we studied about what is pressure relief valve and about direct operated pressure relief valve and pilot operated pressure relief valve. And in today's class, we'll start with the next one, that is the pressure reducing valve and pressure sequence valve. These two we'll see in today's class. So let's start with what is pressure reducing valve. So pressure reducing valve is also called as pressure regulator. So diagram shows a simple pressure reducing valve which contains following components: uh, a conical poppet, inlet which is called as upstream, outlet which is called as downstream. Why they are called as upstream and why they are called as downstream, we'll see it. Then a screw rod to adjust the spring pressure, then a spring and a diaphragm. So these pressure reducing valves are mainly used to maintain a constant reduced pressure at necessary or specified locations in an hydraulic system. These are normally open type of pressure reducing valves. So here inlet port will be having a high pressure fluid. The fluid which is entering at the inlet of a pressure reducing valve will be having a high pressure fluid, so which is called as upstream, and the outlet port which is maintained at a constant pressure, constant reduced pressure, so which is called as downstream. So this pressure reducing valve is actuated by the outlet pressure. Initially when we pass the high pressure fluid at the inlet, it will pass through a gap at the conical poppet and will collect below the diaphragm. So as the pressure at the inlet is more than the set pressure of a spring, the diaphragm will move upwards and hence conical poppet will close the fluid flow. On the right hand side you can see a symbol used for pressure reducing valve. We will study pressure reducing valve by taking an example in the next slide. Now let's see a pressure reducing valve by taking an example. Say if a pump has a pressure of 200 bars at the upstream as shown, and we want to maintain a pressure of say 150 bars in an actuator. So in that case we will use a pressure reducing valve so that we can reduce the pressure of a fluid which is coming from the pump from 200 bar to 150 bar. So this is how a constant reduced pressure is maintained at the outlet, that is at the downstream of a pressure reducing valve. Now let's see the difference between a pressure relief valve and a pressure reducing valve by taking an example, a hydraulic system as an example. So before we see the difference between a pressure relief valve and pressure reducing valve, we should know what is a working pressure and what is a system pressure. So working pressure is nothing but the maximum pressure below which your pump or an actuator works, whereas system pressure is the actual pressure which is produced by the pump. Now we will see the difference between what is a pressure relief valve and a pressure reducing valve by taking an example of a hydraulic circuit showing two actuators, one working under a working pressure of 200 bar, the other one with 150 bar. Even the direction control valves are all shown for both the actuators in order to control the extension and retraction of the actuator, and a pressure relief valve and a pressure reducing valve. And the pressure of a pump is 200 bar. So if the pump pressure becomes more than 200 bar, the pressure relief valve will open and excess pressure fluid will be sent back to the tank. If this pressure relief valve is not present, it might happen that actuators or the pipes or the direction control valves or the components present in this part of a circuit may get damaged. Okay, so that is the function of a pressure relief valve. If the pressure is higher, as we have seen in the previous class, if it goes beyond the system pressure, so pressure relief valve will open and the excess fluid will be flown back to the tank. Now in case of second actuator, the working pressure of a second actuator is 150 bars. That is, your second actuator is designed for a working pressure of 150 bar. But since the pump pressure is 200 bars, we have to reduce the pressure to 150 bars so that in order to operate the second actuator. In order to operate the second actuator, in order to reduce the pressure from 200 bars to 150 bars, a pressure reducing valve is used. So this is how is the difference between a pressure relief valve and a pressure reducing valve. If a pressure is maximum, that if the system pressure is maximum than the set pressure, your pressure relief valve will open and the excess fluid will flow back to the tank. Now if the same pump is used for in order to operate some other system and the system has a pressure less than the pump pressure, in order to reduce that pressure, pressure reducing valve is used. Now we'll move on to the next type of pressure control valve, that is pressure sequence valve. Pressure sequence valve is used in an hydraulic system to do various operations in a definite or a sequential order, one after the other. The working principle of this pressure sequence valve remains same that of pressure relief valve, but this pressure sequence valve is used to control the sequence of operations and it is not used as a safety valve. Whereas pressure relief valve is mainly used for safety purpose, whereas pressure sequence valve is used for to control the sequence of operations. So as shown in figure, there are 3 cylinders which are to be operated one after the other. First cylinder A will be operated or extended. Similarly for second and cylinder B and cylinder C. As the cylinder A extends completely, pressure of fluid starts increasing at the sequence valve 1, hence it will be opened. The fluid flows through the sequence valve 1 and next extends the cylinder B completely. As the pressure of fluid starts again increasing in the sequence valve 2, this sequence valve will be opened and then the fluid flows through the sequence valve 2 and then starts flowing to the cylinder C, thereby extending the cylinder C. In this way, all the cylinders will be extended one after the other. First cylinder A, then if the pressure exceeds, then sequence valve 1 will open, then cylinder B will extend, then if again the pressure exceeds, sequence 2 valve will open and the fluid will flow through cylinder C and this will be extended, and so on. This is how the pressure sequence valve will be operated. And on the right hand side you can see a symbol used for pressure sequence valve. Now let's take only a pilot operated pressure relief valve to see how the sequence of operation take place in this valve. In this valve, the fluid flows freely through the primary passage to operate the first phase until the pressure setting of the sequence valve is reached. That is, the pressure setting of this spring is reached. When the spool lifts, the flow is diverted to the secondary port to operate the second phase. This is how the sequence of operations take place. First phase and in the second phase. So in today's class, we have seen what is the pressure reducing valve. Then by taking an hydraulic circuit, we compared the pressure relief valve and pressure reducing valve. Then we have studied what is a pressure sequence valve. And in the next class, we will study the remaining pressure control valves.